Hello, welcome to concavity, or lesson 11. This is about the third time I've started this, and the other two have been a few seconds long. And my husband said, maybe you should do a thing of outtakes. The problem is I delete them before I could do the outtakes. And so, but one of my students in a different class said that, that they thought it was really funny that I had said, this is the fourth or fifth recording of this video. And so, and my husband's like, I always try to sound so professional in mine. And I'm like, no, I think it's funny when you try to make it sound real. And he's like, oh, no. All right, let's get on to the lesson. Concavity tells us the curvature of the graph. So it tells us whether it goes real steep or whether it's a curve, how much it's curving. So if the second derivative is going up, then it tells us that the curve is going to be a smile, that it's going to look kind of smilish. If it's going down, then it tells us the curve is going to be a frown. So the way I tell my students to remember it, if it's down, then frown. So if you're down, then you typically frown. Okay? An inflection point is, by definition, where the graph changes concavity. The way we find possible inflection points are by setting the second derivative equal to 0 and solving. So what we're going to do is we're going to say f double prime of x equals 0, solve. So x equals c, and these are possible. Unlike when we set the first derivative equal to 0, we actually get relative max or mins. These are possible. Okay, now let's look at this example. So this is the same example from the last graph, from the last section, but what we're doing here is we are finding where it's smiling. So if I look from here to here, I'm looking like I'm going down. I'm looking like a frown, so I'm looking like this, so I'm frowning. So from negative infinity to negative 6, I'm concave down. And I have an inflection point from negative 6 to 10. And then from negative 6 to 10, from there to here, I'm concave up. So from negative 6 to negative 1, I'm concave up because I'm smiling. Then here, I'm trying to make them look the same. I'm going down again. So this is union negative 1 to 1. And I have another inflection point at negative 1, 10. And then here, I'm going up again. So union 1 to infinity. And so I have another inflection point at 1, 10. Notice that I only wrote the inflection points when I actually was changing concavity. I don't write them unless I'm changing concavity. All right? So now we're going to talk about how to determine inflection points. Okay? So, and I may cut this lecture a little short and do some examples, just because some of these examples, I may cut this lecture a little short. There is another technical difficulty. I moved my mic so I could take a sip. Cut this lecture a little short because the process gets a little in detailed And like example number 3 is exactly like one of the examples from the last section. And so what I may do is go on to doing some other stuff so that you can see all the details in the notes, just to make your videos not be quite so long. Or you can, I don't know. We'll see. All right, so here's again where you break your paper up into 3 columns. And the reason I do this is so that when I used to do this horizontally, so what I used to do is I used to do it down the paper. There. Let's do that. So what I used to do is I used to do it where you would do the top portion and then the next portion and then the bottom portion. And I used to do it horizontally instead of breaking it into columns. I used to break it into rows. The students would get lost into which portion they were doing. And then I started breaking it into columns and they could follow it a little easier. So again, this first column is everything to deal with your original function. So this is 3x squared minus x cubed. And so first thing we're going to do is we're going to find the y-intercept, which is 0, 0. The second column is the derivative. So this is 6x minus 3x squared. And the third column, and this is used to find increasing, decreasing, relative max, and relative min. We are not doing this in this example. We're only looking at concavity. So now we're going to find the second derivative, which is 6 minus 6x. All right? And so let me put a little x in there. So now we're going to set that to 0. So that's 6 times 1 minus x. So x equals 1. I deliberately factored this out. I want factors. Remember how we do our sign chart where we put them into the factors. I want factors. I don't want to set this up and solve it like a linear equation. I want the factors so that it's easier to put the values of my sign chart in. So I'm going to use 0 and I'm going to use 2. So if I put 0 in here, I get a positive times a positive. So I get a positive. If I put 2 in here, I get a positive times a negative. So I get a negative. If I'm positive, I'm smiling. If I'm negative, I frown. Have you ever looked at somebody who's always complaining and always rah, 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 and you ever notice how they always look like they're frowning? They always look like they're mad. So if they're negative, they frown. Okay, they're concave down. So if I'm concave down, I'm from 1 to infinity. If I'm up and happy, I'm from negative infinity to 1. I go back to my original and say f of 1 equals 3 minus 1, which is 2. So I'm at the 1, 2, and that's the point 1, 2. And that's it. That's all you do. Notice, and I also want to put an f double prime here, so I realize that I'm putting everything into the second derivative. Notice, this is the same process that I used for the first derivative. It's the same process that I found when I did sign charts back for inequalities. All right, I'm doing the same process over and over and over again. All right, so now let's look at how to sketch this curve. Okay, and this is the one that I was saying was from the last section. Okay, and in the notes, I reworked all the parts that came up from the previous. So again, we're going to divide our paper into 3 columns. Okay, so f of x equals x plus 2 squared times x minus 1. F prime of x equals, and I'm going to go straight to the simplified derivative from the first 3x times x plus 2. That's the simplified derivative from last section. So I found that x equals 0 and negative 2. And my sign chart was negative 2, 0, plus, minus, plus. So I had plus, minus, plus. And so here I had the points 0, negative 4, and I had negative 2, 0. Now to find my second derivative. Okay, and this again is the product rule. So this is the product rule, which is f g prime, which is f prime g minus, which is f g which is f g prime, which is f is 3x, so f prime is 3, and g is x plus 2, so g prime is 1.